Hi everyone. In this video, we're going to be doing A-level Maths 9709, paper 15, Pure Maths 1 Major 2025. This paper is 1 hour 50 minutes long, so try to finish within that time limit. So without further ado, let's get started. Okay, so we're given this equation of a curve is such that dy dx is equals to this. So we're given an expression of dy dx in terms of x, and we're also told that the curve passes through the point 2, 4. And using all this info, we have to find an equation of the curve. Okay, so to find the equation of a curve, we're going to have to find an expression of y in terms of x. We have to express y in terms of fx. And since we're given dy dx, we're going to have to integrate it with respect to x. So let's do that. So to get y, we have to integrate dy dx with respect to x. So y would just be the y would just be the integral of 12 times 2x minus 5 squared plus 8x dx. Excuse me. Okay, so let's integrate it. So first we'll integrate the first 12 times 2x minus 5 squared. So to integrate that, you ignore the constant term, which is 12, and you integrate. Okay, so as I was saying, you leave 12 out of the um, you leave 12 out because it's a constant. So we're just going to integrate 2x minus 5 squared. So to do that, you have to add 1 to the power. So you'll get 2x minus 5 cubed. And you divide by that new power. And also you should divide by the derivative of the inner function. So 2x minus 5, the derivative will just be 2. So this is the first integral. Now we'll add it with the integral of 8x. So to integrate that, again, you leave out the constant term 8 and you integrate x only with respect to the x. So to do that, again, add 1 to the power, so you get x squared, and you divide by the new power, which is 2. And don't forget to add your c, your constant term. Okay, now we can simplify all these. So 12 divided by 3 times 2, that's 12 divided by 6, so that's just 2 times 2x minus 5 cubed, plus 8 divided by 2, that's 4x squared plus c. Okay, so this is our equation. Now we're going to just have to find the plus c to get done with this. Okay, so to do that, we're going to use our second piece of info where it says the curve passes through this point, 2, 4. So we're going to substitute x equals to 2, since 2 is the x coordinate, and y equals to 4. Okay, so let's substitute. So 4 equals to 2 times 2, that's 4. 4 minus 5, that is negative 1 cubed, plus 4x squared, so 4 times 2 squared, so that's just 4 times 4, that's 16, plus c. So you would get 4 equals to 2 times minus 1 cubed. Minus 1 cubed, that's just minus 1. So 2 times minus 1, that's minus 2, plus 16, that's 14, plus c. And hence you will get c is equal to 4 minus 14, which is minus 10. Hence, our final answer would just be y equals to 2 times 2x minus 5 cubed plus 4x squared minus 10. So this would be our final answer for this question. Let's head on to the next question. Okay, so in this question, we're told that in the expansion of this whole expression, the coefficient of x squared is 6 times the coefficient of x. And we're going to have to find the possible values of a. Okay, so what do we notice about this expression here? That both of them are binomial terms raised to a positive integer. So to expand these, we're going to have to use our binomial expansion formula, the first one, where n is a positive integer. So we're going to have to use this to evaluate each of this. So let's evaluate them separately. So let's first evaluate 3 plus ax5. Okay, yeah. We're just going to evaluate until we're just interested in the terms in x and x squared. Okay, you know what? There's a much better way to do this. So instead of expanding the whole thing out for each of our each of our expressions, we can just find a formula for the general term, which is right here, kind of. So instead of like having a number here, you're just going to replace it with r. So n choose r times times a to the power of n minus r times b to the power of r. So this would be our general term formula. Okay, so this would, and also realize that when r is equals to 3, this is the first, second, third, the fourth term. So it's the r plus 1 term. So our formula for a general term would be t r plus 1 equals to n choose r times a to the power of n minus r times b to the power of r. All right, now let's find the term for 3 plus ax to the power of 5. So tr plus 1 is equals to n is equal to 5. So this is 5, choose r. So this r we can find out later. And a is 3. So 3 to the power of n minus r. So 5 minus r times b to the power of r, which is 8x to the power of r. Okay. Now we're going to simplify this and keep the r separate. So we're going to split the powers in here using our law of indices. So this would just be 3 to the power of 5 minus r times a to the power of r times x to the power of r. Okay, so this is our general term. Now we can find the value of r for the term in x and x squared. Okay, so to get the term, so this part would be our coefficient, and this is the x squared or x. Okay, so for 3 plus ax to the power 5, when r equals to 1, okay, let's just equate x to the power of r equals to x. And this would give you r equals to 1. So our coefficient of x will just be 5, choose 1, times 3 to the power 5 minus 1, which is 4, times a to the power of 1. So simplifying all this, 5 choose 1, that is 5 times 3 to the power of 4, that's 405. So we get 405a. And now let's find the coefficient of x squared. So yeah, x squared, then obviously r would just be equals to 2. So coefficient of x squared is equals to 5 choose 2 times 3 to the power of 5 minus 2, which is 3 to the power of 3, times a to the power of r, so a squared. So 5 choose 2 times 3 cubed, that's 270 a squared. So these are our coefficients for our first expansion, 3 plus ax to the power 5. Now let's do it for 6 minus x to the power 4. So 6 minus x to the power 4. So general term would just be n choose r, so 4 choose r times a, which is 6 to the power of 4 minus r, times negative x to the power of r. Okay. Okay, now let's just separate the x terms, okay? So you would get 4 choose r times 6 to the power 4 minus r. You split the power into negative 1 and x, so you get negative 1 to the power of r and x to the power of r. So here we can equate x to the power of r to x, and we'll get r equals to 1. And using this, we can find the coefficient of x. So coefficient of x, it would just be 4 choose 1 times 6 to the power of 4 minus 1, which is 6 cubed, minus 1 to the power of 1, which is just minus 1. So just type this into your calculator. You would get minus 864. And it should be possible, so, obvious. So we'll just sub r equals to 2 to find the coefficient of x squared. So this is just 4 choose 2 times 6 to the power of 4 minus 2, which is 2, and minus 1 to the power of 2. So this will just be 4 choose 2 times 6 squared times negative 1 squared. We'll get 216. So these are our coefficients of x and x squared. Now we're going to add up to find the final coefficient. Okay, because like we're adding up our expressions. So when they're expanded, obviously, you're gonna have to add up the separate x terms and x squared terms. Okay, so coefficient of x squared is 6 times the coefficient of x. So we'll just multiply by 6 the coefficient of x. So coefficient of x is 405a plus, and never mind, plus negative 864 equals to 270a squared plus 216. Okay, now let's simplify this. So 4, 5 times 6, that's 2430A minus 864 times 6, you get minus 5184 equals to 270A squared plus 216. Let's move all the terms to the right-hand side. So we'll get 270A squared minus 2430A 216 plus 5184. We'll get plus 5400 equals to 0. So as you can see, we obtained a quadratic equation in terms of A. And since all the coefficients are big, let's try to simplify them. Let's try dividing by 30. Okay, I think we can divide by 90. Yep, 327 60. Okay, let's divide. Oh my, wait. Let's try dividing by 180. Never mind. Let's just stick to 90. 2430. Get 327. Okay, let's divide by 270. Okay. Yep, 270. Okay, it all simplified out. So you'll get A squared minus, I'm sorry, minus 2430 divided by 270, you get 9A plus 5400 divided by 70, you get plus 20 equals to 0. So now we can finally solve this. Let's you can either factorize or use the quadratic formula. So I'm gonna try factorizing first. Okay, so I got A minus 5 times A minus 4 equals to 0. Now we can equate each of these terms to 0. Each of the factors to 0. So A minus 5 equals to 0. We'll get A equals to 5. And equating A minus 4 to 0, you'll get A equals to 4. So these two are final answers for this question. Let's head on to the next question. Sorry. Okay, so for the first part of this question, we're told to complete the square to find the exact solutions of 4x squared minus 4x minus 1 equals to 0. Okay, so let's first write down our original equation. So we have to first complete the square in order to solve this equation. So to do that, we have to first make sure our coefficient of x squared is 1. So we'll divide this whole equation by 4. So this would be x squared minus x minus 1 over 4 equals to 0. Okay, and now to put bracket x minus the coefficient of x divided by 2. So coefficient of x is 1. Okay, I mean we put a minus sign because there's a negative sign in front of x, and we'll take the absolute value of the coefficient, so that 1, and divide by 2. So this would just be half. So 1/2 squared, and you minus half squared. So that's just minus 1 over 4 minus 1 over 4. That's equals to 0. Okay, let me see if I have any mistakes in here. Okay. Okay, let me just let me just see. Okay, I don't. Okay, we're good. Okay, so let's simplify this. So minus 1 over 4 minus 1 over 4, that's minus half equals to 0. Now we're going to move the constant term over to the right-hand side. So x minus half squared equals to half. Now we can take the square root on both sides. So we'll get x minus half equals to plus or minus square root half. So let's write the positive solution first. So x minus half is equal to the positive square root of half. So this is just 1 over square root 2 or a negative square root. So this is just minus 1 over square root 2. All right. Now let's just add half to both equations. So 1 over square root 2 plus half a. Let's simplify this. So we're going to rationalize the 1 over square root 2. So this would be square root 2 over 2 plus 1 over 2. You would get square root 2 plus 1 over 2. This is our first solution. And now we're going to do the same with this. So this is just half minus 1 over square root 2. So this would just be from, this is square root 2 square root 2. So 1 minus square root 2. So this is our other answer. So these two are our final answers. And if you want to check whether your solutions are correct, just substitute these two values back into your equation and see if you get 0. So without further ado, let's head on to the next part. Okay, so for this part, hence, we're gonna have to solve this trig equation for this domain of theta between 0 and 180. Okay, so first of all, take note of the keyword hence. So hence means we're gonna have to use our answers from the previous part to solve this question. Okay, so let's see how we can do this. Okay, let's first write down the equation for tangent theta equals to 4 plus 1 over tangent theta. So let's first try to make this into a quadratic that is very similar or this is the same as this. So first of all, let's multiply both sides by tangent theta. So for this, you'll get 4 tangent square theta equals to 4 tangent theta plus 1. Now let's move everything to the left-hand side. You would get 4 tangent square theta minus 4 tangent theta minus 1 equals to 0. So as you can see, this is a hidden quadratic in terms of tangent theta. So let's just do a simple substitution. So we'll let t be equals to tangent theta. So you'll get 4t squared minus 4t minus 1 equals to 0. And if you realize that, you will realize that this quadratic equation is the exact same as our quadratic equation that we solved in the previous part. So immediately we can just straight away write the solutions for t, which is 1 plus square root 2 over 2 and 1 minus square root 2 over 2. And now let's substitute back the tangent theta. So this would just be tangent theta equals to 1 plus square root 2 over 2. And this would be tangent theta equals to 1 minus square root 2 over 2. Okay, so let's see whether the values are positive or negative. Okay, so this first value is positive, and then this value must be negative. So let's draw a unit circle first. So the quadrants for which tangent is positive is A, S, T. So T and A is where tangent is positive, and S and C is where tangent is negative. So for tangent theta equals to 1 plus square root 2 over 2, theta can only be in here and here. So to find the angle in the first quadrant, the angle will just look like this. So you just have to find the basic angle. Oh, sorry. We forgot to take into account our domain. So our domain only covers the first two quadrants. So this is 0 degrees all the way to 180 degrees. So you can ignore these two. So our first answer will only be in the first quadrant. So just find the basic angle. So theta would be equal to tangent inverse 1 plus square root 2 over 2. Okay, now type it into a calculator and make sure your calculator is in degree mode because the domain is given in degrees. So we'll get 50.4 degrees to 1 decimal place. Answers in degrees should always be given to 1 decimal place. Take note of that. Okay, and then for second tangent value, since it's negative, it's going to lie down in here, and the angle must be an obtuse angle, and this would be our basic angle in here. Okay, so to do this, take theta equals to minus 180 minus the basic angle, which is tangent inverse the absolute value of this. So that's just square root 2 minus 1 over 2. Okay, so see if it's positive. Okay, it is. So 180 minus that, you will get 168.3 degrees to 1 decimal place. So these two are our final answers for this question. And if you want to, again, check your answers, just substitute the exact values back into this equation on both sides and see if both sides match. So without further ado, let's head on to the next question. Okay, so for this question, we're given this diagram which shows part of this curve and the shaded regions bounded by the curve, the line. Okay, all this is shown in the diagram. And for this, we have to find the volume formed when the shaded region is rotated through 360 degrees about the x-axis, giving your answer correct to 2 decimal places. Okay, so first of all, we should know the formula for calculating the volume formed when a shaded region is rotated 360 degrees around the x-axis. It would just be pi y squared with respect to x. Okay. And then here would be our upper limit and our lower limit. But we're not given our lower limit here. So first we're gonna have to find that out. So let's find out our y squared and our lower limit. Okay. So to find the lower limit, it's basically just the value of x when y equals to 0 for our curve. So let's just substitute y equals to 0. So this would just be x squared minus 1 over x squared equals to 0. And now we're going to multiply both sides by x squared. So this would be x squared squared minus 1 equals to 0. And now we can move the 1 to the other side. So x squared squared would just be equals to 1. And now we can take the square root on both sides. So x squared would just be equals to plus or minus 1. So x squared would be 1 and x squared would also be negative 1. So we're going to reject this value because we know that x squared is always greater than or equal to 0. Now let's take the square root again. We'll get x equals to plus or minus 1. And we can clearly see from our diagram that the lower limit is more than 0 because it's to the right of the y-axis. So again, we're going to reject negative. So hence x is equals to 1. So our lower limit is 1. Okay, now let's figure out what y squared is. So y squared is just x squared minus 1 over x squared, whole thing squared. To explain this, we're going to use our a minus b squared identity, a squared minus 2ab plus b squared. So a is x squared. So x squared squared, that's just x to the power 4 minus 2a, which is just x to the power of 2 times b, which is 1 over x squared plus minus 1 over x squared squared, which is just 1 over x to the power 4. So the x squared cancels out. Y squared would just be equals to x to the power 4 plus x to the power of negative 4. Yeah, we're changing the power in here to a negative power minus 2. So this is our expression for y squared. Now we're ready to integrate. So upper limit would be 2, lower limit would be 1, pi times y squared, which is x to the power of 4, plus x to the power of negative 4 minus 2 dx. So let's take out the pi first since it's a constant, and let's integrate this whole function here. So let's first integrate x to the power 4. So to do that, just add 1 to the power. You'll get x to the power 5, and you divide by the power. And then you add it with the integral of x to the power of negative 4. You do the same process again. So add 1 to the power, you'll get x to the power of negative 3, and you divide by the new power, and you subtract with the integral of 2 with respect to x. So for this, you just have to add an x. And don't forget to plug in your limits. Okay. Now let's put our limits in. So let's put the upper limit first. So just type into your calculator this whole expression. So 2 over 5 plus 2 to the power of negative 3. Negative 3 divided by negative 3 minus 2 times 2. We'll get, okay. Okay. So this is 283,120 minus when you substitute 1. So you got 1 to the power 5 over 5 plus 1 to the power of negative 3 divided by negative 3 minus 2 times 1. You will get minus negative 32 over 15. So now let's type the remaining expression into your calculator and give your answer to 2 decimal places. So let's do that. get 14. It would get 14.11 as your final answer, units cubed. So this would be our final answer to 2 decimal places. Okay. And if you want to check whether your answer is correct, you can just type this exact integral into your calculator with the limits and see if you get the same answer. So without further ado, let's head on to the next question. Okay, so for this question, we're given this diagram which shows the sector ABD of a circle with center A and radius 10 centimeters. So here AD will also be 10 centimeters. The perpendicular bisector of AB passes through D. Okay, so the perpendicular bisector is CD. Yeah, as you can see here, I'm gonna mark it in blue. Okay, so for the first part, we have to find the perimeter, the shaded region, BCD, giving your answer correct to 1 decimal place. Okay, so here we're gonna have to find the perimeter of this whole area, of this whole shaded region. So to do that, we first have to know the arc length of this sector, which is arc DB. So to do this, refer to your MF19, and we're gonna have to use this formula, S equals to R theta. So arc EB would just be equals to R theta. Okay, and the theta is this angle DAC, DAB. And to find that out, we can use our trig ratios. So theta, you can see, is just equals to cosine inverse 5/10. So R is 10, and then theta is just cosine inverse 5/10. Okay, so cosine inverse 5/10. Make sure your calculator is in radian mode for this. So okay, we'll get 10/3 pi. Let's leave all of our let's leave all the answers in exact form for now until we get to our final answer. Like if you round way too early, your final answer would be way off to the correct answer. So at first, it's always best to maintain an exact form, or if you can't, express it to a higher number of significant figures or decimal places, like 3 decimal places or 4. Okay, so anyway, we know CB, so now we have to find the length of DC. And as you can see, there's a right angle triangle in here, so we can use Pythagoras theorem to find DC. So DC is just, DC squared is just dA squared minus AC squared. So DC, which is square root of dA squared, which is 100, minus AC squared, which is 5 squared, which is 25. So that's just 75 squared. So 75 squared is just 5 times square root of 3. Okay. Now we can find the perimeter by just adding up all these lengths. So 10/3 pi plus 5 square root 3 plus 5. Type it into a calculator. You'll get 24.1 centimeters. Don't forget your units to 1 decimal place. So this is our final answer for this part. Let's head on to the next part. Okay, so for this part, we're gonna have to find the area of the shaded region BCD. Again, giving your answer correct to one decimal place. All right, so let's look at the shaded region again. So to find the area of this region, you have to find the area of the whole sector minus the area of this right angle triangle. Okay, so first let's find the area of the sector. So sector, what's the sector called? Okay, ABD. To find the area of that, refer to formula sheet, and we have to use this formula in here. Half r squared theta, and theta must be in radians. So half r is just a radius, so that's 10 squared. And then theta is just this angle in here, which is pi over 3. Leave your answer in exact form, and basically in terms of pi, okay, you will get 50 over 3 pi cm squared. Okay, and now you have to find the area of this triangle here. So since it's a right triangle, it's a triangle ACD. So triangle ACD, just take half times base. Base is 5 times the height, which is DC, so 5 square root 3. And you would get 25 over 2 square root 3 centimeters squared. Okay, so now BCD will just be the area of the sector minus the area of the triangle. So this would just be equals to 30.7 centimeters squared in one decimal place. So this is our final answer for this part and the whole question. Let's head on to the next question. Okay, so for this question, we're told that each year on her birthday, Ananya receives some money from each of her parents, and then on her first birthday, her father gives her $10, and every subsequent year, her father gives her $5 more than the previous year. And then on her first birthday, her mother also gives her $10. And every subsequent year, her mother gives her 20% more than she gave her the previous year. And for the first part, we have to show that on Ananya's 11th birthday, she receives more from her mother than from her father. Okay, so let's try to form like a sequence in here. So from her father, she gets $10 in the first year on her first birthday, and then second birthday would be 15, then 20, and then 25. So as you can see in the sequence to get the next term, you just have to add 5. So this is an arithmetic progression. Okay, so for this AP, common difference is 5 and first term is 10. So now we can find UN, which is given in your MF19. Sorry. Yep, here. So you have to use this formula, UN equals to A times N minus 1D. So UN equals to A plus N minus 1D. So U11, since we want to find out how much she receives on her 11th birthday, it's just the first term plus N minus 1, which is 10, times 5. So it would be 60. So she gets $60 from her father. Okay, and now let's look at her mother. So let's also try to form a pattern in here. So first she gets $10, and then the next year she'll get 20% more. So that's just 120%. I mean, times 120%. So you don't have to find the term. And then the next one also times 120%. And 120%, it's equivalent to multiplying by 1.2. So as you can see, to get the next term, all you have to do is multiply by 1.2, and hence this is a geometric progression where the common ratio is 1.2. And the first term is 10. So let's find the general term formula for a geometric series. So it's right here. Un equals to a times r to the power of n minus 1. Okay, times r to the power of n minus 1. So U11 would just be a, which is 10, times r, which is 1.2 to the power of n minus 1, which is 11 minus 1, that's 10. So you get 61.92 to 2 dp, since this is money. So hence, Ananya gets $61.92 from her money. And hence we can conclude that Ananya receives more from her mom and her father. Her mother than her father. So we can write show. So this is the final answer for this part. Let's head on to the next part. Okay, so for this next part, we're gonna have to find the total amount of money Ananya receives up to and including her 18th birthday. So basically, they're asking us to find the sum of money she gets from both her mom and dad all the way until her 18th birthday. Okay, so to find this out, let's find for how much she gets from her father first. So as we established in the previous part, this is an arithmetic progression where the common difference is 5 and a is 10. And to find out how much she receives, like in total, like cumulatively from her dad, we're gonna have to find the sum of all the terms up to the 18th, the first 18 terms of this progression, right? So let's look at our MF19 for the summation formula. So we're given two formulas in here. This one, which requires you to know L, which is the last term. Or we can use this longer formula, which doesn't require you to know L. It just requires you to know N, A, and D. So we're going to use the second one. So half N times 2A plus N minus 1D. So we are going to have to find the sum of the first 18 terms. So N is equals to 18. So half times 18, that's 9, times 2A, that's 2 times 10, which is 20, plus N minus 1, which is 18 minus 1, that's 17, and then D is equal to 5. So she will receive in total, she would have received $945 from her dad. So $945 from father. Okay, and now we're gonna find how much she received from her mother. So as we established previously, to get the next term, you have to multiply 1.2. So this is a geometric progression of common ratio 1.2 and first term 10. And to find the total amount of money she received in all of her birthdays up until her 18th birthday, we're going to have to find the sum of the first 18 terms. Okay, so let's look for the general formula for the summation. So it's basically this formula right here, Sn equals to a times 1 minus r to the power of n over 1 minus r. So let's write it down. So since we're interested in knowing how much you receive up until her 18th birthday, we have to again find the sum of the first 18 terms. So this is a times 1 minus 1.2 to the power of 18 over 1 minus 1.2. You just type it into your calculator. You would get 1281.17 to two decimal places because this is money. Okay, so hence she gets $1,281.17 from her mom. Okay, and now we're just gonna add these two numbers up. So 945 plus 1281.17. It's equals to 2226.17. So this is our final answer for this part. Let's head on to the next question. Okay, so in this question, we're told that in the parallelogram ABCD, the coordinates of A are 3, 7, B is 6P, and D is 1P. And it is also given that the gradient of AB is minus 2/3. And for the first part, we have to find the value of P. Okay, so to do that, let's first find the gradient of AB in terms of P. So to do that, just take the y-coordinate of B, which is P, minus the y-coordinate of A, which is 7, over the x-coordinate of B. X-coordinate of B minus the x-coordinate of A. Yeah? Yep, x-coordinate of A. Okay. This would be equal to P minus 7 over 6 minus 3, which is 3. So P over 7 over 3. Now equate this to AB, the gradient of AB, which is minus 2/3. Okay, now let's cross multiply. So this is 3 times P times P minus 7 equals to minus 2 times 3. Now we can divide by 3 on both sides. So we get P minus 7 equals to minus 2. Then you'll get P equals to 7 minus 2, which is 5. So this is our final answer for this part. Let's head on to the next part. Okay, so now we're gonna have to, for this part, we're gonna have to find the coordinates of C. Okay, so to do this, let's draw a sketch the parallelogram. So it's like A, B, C, D. Yep, A, B, C, D. Yep, this is our parallelogram. And as we can see, AB is parallel to DC, and BC is parallel to AD. So we can use this property to find out the coordinates of C. So first we're gonna let C be just x comma y. All right. So let's find the gradient of CD. So that would just be the y coordinate of C, which is y minus the y coordinate of D, which is y coordinate of D. That is just P, which is 5 over x minus x minus 1. Sorry, x minus 1. Okay, yep. Yeah, just double checking. Yep. And this is equal to the gradient of AB since they're parallel. So minus 2/3. Now let's cross multiply. 3 times y minus 5 is equals to minus 2 times x minus 1. So this would just be 3y minus 15 equals to 2 times minus 1, that's 2. Minus 2 times x, that's minus 2x. Now let's move all the x and y terms to the one side. So this is 2x plus 3y, and all the constant terms to the other side. So 2 plus 15, that's 17. So this is our first equation. Now let's find the second equation using the other set of parallel lines. So here we're going to find the coordinate of the gradient of BC. So that is just the y coordinate of C minus the y coordinate of B. Y coordinate of B is just P, again, y minus 5 over x coordinate of C minus x coordinate of B, which is 6. And this is equal to the gradient of AD. So gradient of AD, that is just y coordinate of D, which is P, minus the y coordinate of A, which is 7, over the x coordinate of D, which is 1. Sorry, 1 minus the x coordinate of A, which is 3. Okay, so now we can cross multiply. So 1 minus 3, that is minus 2. Minus 2 times y minus 5 equals 2. 5 minus 7, that's also minus 2 times x minus 5. So we can cancel out the minus 2's, and we'll get y minus 5 equals to x 6. And now just make y the subject. So this would be x minus 6 plus 5, which is x minus 1. So this is our second equation, and now we can solve this simultaneously. So to solve this, we're just going to substitute 2 into 1 since 2 is in terms of y. So we get 2x plus 3 times x minus 1. X minus 1 equals to 17. So 2x plus 3x, that's 5x. Plus 3 times negative 1, which is minus 3, equals to 17. And solving this, we get 5x equals to 20, and x would be 4. And now let's find what y is. So y is just 4 minus 1, which is 3. So c would be equal to 4 comma 3. So this is our final answer for this part. Let's head on to the next part. Okay, so for this part, we're gonna have to find the area of the triangle formed by the perpendicular bisector of AB and the x and y axes. Okay, let's do a little sketch so that we can better understand how the triangle looks like. These are x and y axes and AB. Let's sketch that too. So A is 3, 7. So we'll let A be here. And our B is 6, P. So 6, 5. So that is right here. And the perpendicular bisector will be like this. Yeah. So this is the triangle that they're talking about. And as you can see, it has to be a right angle triangle. So to find the area, we have to know the distance of here, like the distance from the origin to here and from the origin to here. Okay, so to do that, we must first find the equation of the perpendicular bisector. Okay, so as you know, this is AB, and the perpendicular bisector is obviously perpendicular to AB. So to find the gradient of this, AB, So to find the gradient of the bisector, you just do -1 divided by the gradient of AB, which is -2/3, divided by -2/3. So you would get -1 divided by -2/3 equals to 3/2. So this is our gradient of our bisector. And now we're gonna have to form the equation, which is y equals to mx, which is 3/2x plus c. So now we're gonna have to find c. And to do that, we need to know a point that passes through our bisector. And one of the points is the midpoint of AB. Since this line cuts AB into half, so obviously the midpoint would pass through the bisector. So let's find the midpoint. Sorry. Yep. Okay. Midpoint of AB. Of AB. You would get uh A is 3 plus 6/2. 3 plus 6/2, comma 7 plus p/2. So 7 plus p. P is 5/2. So this is equals to 9/2, which is just 9/2, and 7 plus 5, 12 divided by 2, which is 6. So we can substitute that. So 3/2 times 9/2 plus c equals to 6. And then c would just be, c would just be equals to 6 minus 3 times 9 is 27 over 2 times 2, which is 4. Okay, so 6 minus 27/4 is -3/4. So hence This is the equation of our perpendicular bisector, y equals to 3 over 2x minus 3 over 4. All right, so now we can find the distance by finding these points in here, the x and y intercepts. So let's find the x-intercept first. So sub y equals to 0, you would get 3 over 2x minus 3 over 4 equals to 0. Then you'll get 3 over 2x equals to 3 over 4. And then x, you would get 1 over 2, or 1/2. And now we're going to substitute x equals to 0 to find our y-intercept. So this would be y equals to 3 over 2 times 0 minus 3 over 4. We'll get minus 3 over 4. So hence, the distance in here is 3 over 4, and the distance here is 1 over 3. So triangle, the area of the triangle would just be half times x, which is half times 3 over 4. And this would be equal to 3 over 16 units squared. So this is our final answer for this part, as well as this entire question. Let's head on to the next question. Okay, so for this question, we're told that the equation of a curve is this, and the curve has a stationary point at one common line. For the first part, we're going to have to find the value of constants a and okay, so first of all, we're told that the curve has this point in here, like this point passes through the curve passes through this point. So first we're going to sub x equals to 1 and y equals to 9. So this would just be 1 cubed, which is 1, plus a times 1 squared, which is a, plus b times 1, which is b, plus 5 equals to 9. Sorry. Okay, and then this would be just a plus b equals to 3. And this would be a equals to 3 minus b. So this is our first equation. Now we're going to have to form a second equation. So we're also told that this point in here is a stationary point. So this means that dy dx at this point is equal to 0. So now we have to find our dy dx. So let's take our original equation. So to differentiate this, we're going to differentiate each term separately. So differentiating x cubed, you take the whole power 3 multiplied, and then you minus 1 from the whole power, so you get 3x squared. Same for ax squared. So ignore the constant term and just differentiate x squared. So you take the old power multiplied by a, and then minus 1 from the whole power, so you get power 1. And then for bx, keep the b since it's a constant and differentiate x only, so you just get 1. And then plus 5, the derivative of 5, which is just 0 because it's a constant. Okay, now let's equate dy dx to 0. Okay. Now we're gonna again substitute x equals to 1 and y equals to 9. And never mind, you cannot substitute y, just x. So this would be 3 times 1 squared, which is 3, plus 2a times 1, which is 2a plus b equals to 0. So this is our second equation in here. Okay, now we have two simultaneous equations. We have to solve them simultaneously. So since we have an equation purely in terms of a, we are going to use substitution. So we're going to substitute 1 into 2. So this would be 3 plus 2 times a, which is 3 minus b, plus b equals to 0. So it's just 3 plus 2 times 3, that's 6. 2 times negative b, that's minus 2b, plus b equals to 0. So minus 2b plus b, that's minus b, equals to 3 plus 6, that's 9. So you get minus 9. And b would be equals to 9. Okay, and now a is equals to 3 minus b, which is 3 minus 9. Get minus 9 plus 3, you get minus 6. So a is equals to negative 6. So these are our final answers for this part. Let's head on to the next part. Okay, so for this next part, we're going to have to find the coordinates of the other stationary point. Okay, so to do that, let's take our expression for dy dx and substitute the values of a and b. So 3x squared plus 2ax. Yeah, so 2ax, that's 2 times negative 6x. 2 times negative 6x plus b, which is 9. So plus 9 equals to 0. So this would just be 3x squared minus 12x plus 9 equals to 0. So we got a quadratic equation in here. So we can solve this. And to make it simpler, we can divide the coefficients by 3. So this is x squared minus 4x plus 3 equals to 0. Okay, now we can finally solve it. So to do this, just factorize. You can either factorize or use the quadratic formula. So you factorize it. So you get x minus 3 times x minus 1 equals to 0. So equate each factor to 0, get x equals to 3 and x equals to 1. But we already were given the stationary point with the x coordinate 1. So we're going to have to reject this because they want the other stationary point. Okay, so we'll only take x equals to 3. Now, since they want coordinates, we'll have to find our y point. So, yep, so we're going to have to substitute it into there. So y is x cubed plus ax squared. So a is minus 6x squared. So minus 6x squared plus bx. So bx is 9x plus 5. Sorry. Plus 9x plus 5. So this would be y equals to 3 cubed minus 6, 3 squared plus 9 times 3 plus 5 equals to 3 cubed minus 3 minus 6, 3 squared plus 9 times 3 plus 5 equals to 5. Hence, our final answer is 3, 5. Sorry, it happened again. So this is our final answer for this part. Let's head on to the next part. Okay, so for this part, final part, we're told a point P is moving along a part of the curve in such a way that the y-coordinate of P is increasing at a constant rate of 6 units per second. And we're going to have to find the rate at which the x-coordinate of P is increasing when x equals to 5. Okay, so first of all, we're going to form an equation with all this info. So the y-coordinate of P is increasing at a constant rate of 6 units per second. We can write this as dy dt, which is basically the rate of change of y with respect to time. We can equate this to 6 since it's increasing, so the value will be positive. So, and if it's decreasing, it will be negative. And we're going to have to find the rate at which the x-coordinate of P is increasing. So basically, we have to find dx dt. So this is what we have to find. So now we're going to form an equation in terms of dx dt. So to do this, we're going to use our chain rule. So this is, sorry, this is this has to be dx over something times something over dt. And this something has to be the same. So here we can only put dy, and hence we're going to put dy in here as well. And dx dy, that's just the reciprocal of dy dx. So 1 over dy dx times dy dt. So now we're going to evaluate dy dx when x equals to 5. So dy dx equals to, so this is our expression, 3x squared minus 12x plus 9. So 3 times 5 squared minus 12 times 5 plus 9. And this is equals to 3 times 5 squared minus 12 times 5 plus 9, which is 24. So now we can find our dx dt. It's just 1 over 24 times 6. So 6 divided by 124, that's 1 over 4. So this is our final answer for this question. Let's head on to the next question. Okay, so we're told here that functions f and g are defined as follows. So fx is cosine x for x is between 0 and pi, and gx is this more complicated function for x is between pi and 2 pi. And for the first part, we have to describe fully the transformations that have been combined to transform the graph of y equals to fx to the graph of y equals to gx. So basically, we have to know how to transform fx into gx. So to do this, we're going to write the equation of fx, cosine x, and see how they got gx. So for translations, like x and y, you have to do them together. So yeah, you cannot do like, 3 x minus pi. You cannot add minus pi first and then you multiply by 3 and add 2. This is not allowed, okay? All right, so first transformation was multiplying by 3 and then subtracting pi from x, so 3 cos x minus pi, and adding 2 to the equation of the function. So for the first one, from cos x to 3 cos x, we can write vertical stretch vertical stretch, scale factor 3, followed by translation, because translation is basically what happens whenever you add or subtract something from x or the whole equation, followed by translation of, you have to express it in a vector. So in our case, it's pi, since x minus pi equals to 0, you take x equals to pi, and 2. That's the y shift. So because we added 2 to this equation, so obviously the graph would move 2 units up. So this is the final answer for this part. Let's head on. Let's check everything's correct. Okay, everything's correct. Let's head on to the next part. Okay, so in this part, on the given axis, we have to sketch the graphs of y equals to, y equals to fx and y equals to gx. Okay, first let's sketch the curve of y equals fx. So fx is just cosine x for this domain between 0 and pi. So you can only draw between here and here. So for cosine, the graph usually looks like this from 0 to 2 pi. But since we're only doing until pi, we're not going to do this other branch. So it's just going to be this mirrored S shape. So let's draw that. Okay. Yep. So this would be the maximum point, which is 1. And this would be the minimum point, -1. Okay. Yep. So this is y equals to fx. And now we're gonna sketch y equals to gx. So to do this, we need to know the maximum minimum points for y equals to gx. So just sub 1 into the cosine, so 3 times 1 plus 2, that is 5. Okay, so 5 we can draw somewhere here, and the minimum point, it would be when cosine is -1, so you will get -1. 0, yep, you get -1. So this is the minimum point. And the maximum point occurs when x is equals to pi, then you'll get cosine 0, which is equals to 1. And the minimum point occurs when x equals to 2 pi, then you'll get cosine pi, which gives you negative. So our points are here and here. And the middle point, which is where the kind of like shifts. Like so for cosine x, the middle point would be the x-axis. So for this, it'll just be the midpoint. So that's just 2. So sorry. And write 2 in here. Also draw a dashed line. Okay. Okay. We can now finally draw. So this one, okay. So this should be in the middle. Like the curve should be passing through the middle of pi and 2 pi. So this is 3 pi over 2. Yeah. So this is our curve y equals to gx. Okay. So this is our final answer for this part. Let's head on to the next part. Okay, so for this part, we're gonna have to find g inverse f pi over 3. So to do this, we're first gonna have to find f 1/3 pi. And we know fx is just cosine x, so it's just going to be cosine pi over 3. Cosine pi over 3, type it into a calculator, you would get half. So now we can say G inverse F 1/3 pi is equals to G inverse half. So to do that, we first need to find out what G inverse is. So we first have to let y equals to gx. So y is equal to gx, which is 3 cos x minus pi plus 2. So 3 cosine x minus pi plus 2. Now we're going to swap the x's and y's. So this is going to be x equals to 3 cosine y minus pi plus 2. Now we have to let y be y. Now we're going to let y be the subject. So this is going to be 3 cosine y minus pi equals to x minus 2. So it'd be cosine y minus pi equals to x minus 2 over 3. Now we're going to take cosine inverse on both sides. So this would be y minus pi equals to cosine inverse x minus 2 over 3. Now we're going to add pi to both sides to isolate the y. So this would be pi plus cosine inverse x minus 2 over 3. So hence, we can say that G inverse x is equals to pi plus cosine inverse x minus 2 over 3. And now we can find G inverse half, which is this equals to pi plus cosine inverse half minus 2 over 3. And this would just be pi plus cosine inverse half minus 2 divided by 3, which is minus half. And cosine inverse minus half so for this, our answer has to be within the range of gx, within the range of g inverse x. And the range of g inverse x is the domain of gx. So it has to be between pi and 2 pi. So make sure you follow that criteria. So let's take our first answer, which is 2/3 pi. So this would give us 5 over 3 pi, which lies within the domain of gx. So yep, we can accept this answer. So this is our final answer for this part. Let's head on to the next part. Okay, so for this part, we're gonna have to explain why the composite function fg cannot be formed. Okay, so for a composite function like fg to form, the range of the inner function, or g, has to be within the domain of f. So let's see what the domain of f is. So the domain of fx is 0 pi, okay? So let's write down domain of fx is between 0 and pi. And what's the range of gx? So we just look at our graph. It is between -1 and 5. And the range of gx is between -1 gx 5. And as you can see, the range of gx is clearly not within the domain of fx. It's beyond it. So you can say since range of gx isn't within the domain, sorry, domain of fx, fg, and before. So this is our final answer for this part. Let's head on to the next question. Okay, so here we're told that the equation of a circle is this. It's given in the general form. And for the first part, we have to find an equation of the tangent to the circle at this point, given your answer in the form ax plus by plus c equals to 0. Okay, first of all, in order to find this, we have to know what the center of the circle is. So let's write down the equation of the circle. Now, don't like memorize the format of the general form. So if you're like me, you can bring all the x and y terms together and do completing the square and move the 12th over to the other side. So let's complete the square for x. So make sure the coefficient of x squared is 1. So this would be x plus, because there's a plus sign, half of the coefficient of x. So that's 2 squared minus 2 squared, which is 4. Now let's do the same for y squared minus 8y. So this is just y minus 8 divided by 2, 4 squared minus 4 squared, which is 16. That's equals to 12. Now keep all the x and y terms on the left-hand side and move all the constant terms to the right-hand side. So this would just be 12 plus 16 plus 4, which is 32. So this is our equation of the circle in this form: x minus a squared plus y minus b squared equals to r squared, where r is the radius of the circle and ab is the coordinates of the center. So hence, from here, we can say that the center of the circle would be -2, 4. So this is the center of the circle. Now we can go ahead, find the equation. So let's draw a little sketch. So this is the center of the circle, and this is the point we want to find the equation of the tangent to. So this is the tangent, and this is the line for connecting the point to the center of the circle. And one property of these two lines is that they meet at right angles, okay? So we can use this formula, m1 times m2 equals to -1, to find the gradient of the tangent line, where m1 and m2 are the gradients of these two lines. Okay, so first of all, let's find the gradient of m1. So this is going to be m1. So this is c, and then this is 2, 8. So this is 8 minus c. C is 4 over 2 minus -2. And this is equals to 4 over 4. which is equals to 1. So this is the gradient of the line from the center to the point. Now we can find the equation of the tangent by rearranging this formula. So this is just minus 1 divided by 1, which is minus 1. Hence, the equation of the tangent would be in this form. Y equals to min mx, which is minus 1, so minus x plus c. And to find c, we're going to substitute the point. So x equals to 2 and y equals to 8. So this is just minus 2 plus c equals to 8. This would give you c equals to 8 plus 2, which is 10. And hence, our final answer is y equals to minus x plus 10. And to make it into this form, just move everything to the left-hand side. So we add x to both sides, so you get x plus y and minus 10 from both sides. So minus 10 equals to 0. So this is our final answer for this part. Let's head on to the next part. Okay, so for this part, we're told that given the line x plus 3y equals to k does not intersect a circle, we have to show this result here. Okay, first of all, let's write down the equation of this line and the equation of the circle. So x squared plus y squared plus 4x minus 8y plus 4x minus 8y minus 12 equals to, minus 12 equals to 0. Okay, let's change the first equation a bit. Let's make x the subject, so x would just be k minus 3y. So this is the first equation, and this is the second equation. And now we're going to have to solve these two equations simultaneously. So to do that, we'll sub 1 into 2. And we'll get k minus 3 y squared plus y squared plus 4 times x, which is k minus 3y minus 8y minus 12 equals to 0. So to expand this, just use a minus b squared. So k squared minus 2k 3y plus 3y squared, which is 9y squared, plus y squared plus 4k minus 12y minus 8y minus 12 equals to 0. Okay, now this would be k squared minus 6yk plus 10y squared plus 4k minus 12y minus 8y, that's minus 20y minus 12 equals to 0. Now let's gather the terms y squared together. There's only one, so 10y squared. Now the terms in y, so yep, that's minus 6k minus 20y. This is plus k squared k f4k plus 4k minus 12 equals to 0. Okay. Now, if this line doesn't intersect the circle, then there won't be any solutions for this equation. So we're going to use the discriminant in here, and we're going to set this equal less than 0. So we would get b squared, which is minus 6k minus 20 squared minus 4 times 10. So a is the coefficient of y squared, and then c is just the constant term, which is k squared plus 4k minus 12 less than 0. So let's simplify this. So again, let's use a minus b squared. So this is minus 6k squared. So that's 36k squared minus 2 minus 6k times minus 20 plus minus 20 squared, which is 400. Yeah. And this is minus 40 k squared plus 4k minus 12 less than 0. Okay, now let's simplify everything. So 12 times negative 20, which is minus 240k plus 400 minus 40k squared minus 160k minus 40 times minus 12, that is plus 480 less than 0. Okay, now let's collect all the terms in k squared. So 36 minus 40, that's minus 4k squared, and minus 240k minus 160k, that is minus 400k, and 400 plus 480 is 880 less than 0. Okay, so to get this into this form, we're gonna divide the whole equation by minus 4. So this would be k squared plus 100 minus 880 divided by negative 4. Oh, sorry, this has to be k. So this is k minus 220. Don't forget to flip the inequality sign because we divided by a negative number more than 0. Let me see. Okay, something's wrong. Okay, let me just see what I did wrong in here. It's oh, minus 2ab. This is not supposed to be minus. Okay, so this is supposed to be a positive value. Yeah, this k value is supposed to be positive. So this is 240k minus 160k, you get 80k plus 80k. Okay. And then again, we divide by negative 4. So this would be k squared minus 20k minus 220. Don't forget to flip the inequality sign equals to 0. So we finally shown the result. So this would be our final answer for this part. And we have also come to the end of this paper. So I hope you found this video helpful. And if you did, please make sure to like and subscribe to this channel for more past paper solving videos of A-level maths and further maths. If you have any doubts or any future video ideas, please feel free to leave them down in the comments below. And I will see you again next time. Okay, thank you.